Alright guys, I suggest that you go do the mock common test to make sure you have done that before you come and look at these videos. Right, I'll start with question 1 and then question 2 in this video. I do the rest in a couple more videos. The first question, two ways to go about this. You can do this directly. Y is given as follow. You do not have to simplify your derivative. Anyway, you can do just like that, you know, put 3 in front and then this, copy this will be 3 minus 2 and times the derivative of what we did. So this will be 4e to the power of 4x plus 2 1 over x, and just simplify a little bit. I mean, you don't have to, you can stop there, plus 2 ln x power of 2. This is 1, actually 3 minus 1, and this would be 4e 4x plus 2 over x. That's what is required. Of course, I briefly just mentioned you could let u be e power 4x plus 2 ln x, and then using chain rule you get your du dx, whatever that is, and then you get your dy dx using the chain rule, dy du times du dx, and the outcome would be the same. Right? Moving on, part B. Right, so you asked to first simplify the expression using log. So what we do is we take log both sides. I take log, take ln both sides, the left side and right side, and what you get now is ln y be equal to ln this one whole chunk of things here. This it's a rational expression, that's all. And by the rule of log, don't forget ln y, you can express this as follows. This is rational, so it can be like, you know, it's like division, and the rule of log says that this can be re-expressed as a subtraction, a difference of these two function. And this is the first term. Notice that it's actually a product of two functions, and so you can then write like this, plus ln x to the power half. Recall that actually root of x is actually square of x, actually x to the power half. Alright, and this, so rule of log again, ln e, rule of log again, ln x minus nothing much we can do. Oh, my bad, this is ln 4x cubed plus 7. Nothing much we can do with the last term, but the first term, this is actually ln e is 1. You remember that, I hope. So this is 1 actually, right? So finally we get this half ln x, and then ln 4x cubed plus 7. Alright, so then we kind of actually done. You have to simplify, remember, and find dy dx. Right, now the word hence means that you got to use this last line to find dy dx, and remember this is ln y equals to all these things, and by deriving with respect to x implicitly, of course. So what happens to the left hand side, you get, you know, deriving ln y, get 1 over y, but because this is implicit, you have to times by dy dx. Alright, and negative 2x gives negative 2. This is half times 1 over x, and the last bit will be 12x square divided by 4x cubed plus 7. And of course then I simplify this a little bit. So cube plus 7. There's a 2x here, so there's 2x, and you will get a negative 2 times 2x, and then 4x cubed plus 7, and then you get plus 4x cubed plus 7 from this second term, and the last one will be 12 minus 12, or rather 24, 24 x power 3, 24. Yeah. And finally, let me write here more space, so the dy dx will be equal to this whole thing. Now the numerator of this, if I expand this, I will get negative 16x cubed. Now by the way, you don't have to do all this. You can stop just right here and then just get the y over to the other side. I mean, write it, not get it. So this is power 4 plus 20x cubed plus 28x minus 7, and so this is 2x 4x cubed plus 7. And what we're going to do is this last line. This was 1 over y dy dx. If you multiply this whole expression by y, and there's no more y on your left hand side, but now you have a y here, right? Y here. But so you replace y with the value given. Check the questions. The value given is this, not the value, I mean the expression given. It's plus 7, and here you have e to power negative 2x root square root of x. So you can keep your answer as follow. That would be just fine. Alright, cool. Next one, question 2. Question 2 is graphing questions. You need to understand a bit about what is slope and so on. So I'm going to describe a bit about review a bit about slope. Dy dx, and if you have function dy dx is essentially your f prime, means same thing, and this means actually slope of a function. And if you have a horizontal line like this, so the slope of this is so really like 0. And what's the point of me talking about this? Because now look at this part of the curve. If I'm able to extend this, the curve will be like, looks like it's going to flat out. It's going to flat out like really horizontal. So at this part, when x is like really huge, the dy dx, which essentially is the slope, is going to be really close to the value of 0, because it looks just so horizontal. Therefore, to answer part A, deduce the value of y as x tends to infinity. Simple. As x tends to infinity, the f prime x tends to 0. Voila, that's all. That's it. But you have to follow this law, this order. You have to mention that x is tends to infinity, otherwise it means that you don't really know what's going on. And lastly, to sketch the graph of f prime on the same set of accessible, this whole thing here. Again, remember that when you want to find stationary point, now stationary point could be maximum, could be a minimum point, could be inflection too. But as we can see at diagram graph, this is where the maximum is. There's a maximum there, so you will suspect that the dy dx here will be 0. Or of course, remember this is actually f prime, then it will be 0. So we know that the curve of f prime would cut y equals 0 at x equals to 2, and here this is, right? And again, the before 2, x equals 2, the curve itself behaved like positive, right? I know the slopes are all positive, so if you draw imagine there's a tangent line, positive, or this tangent line here, you draw on the curve positive, but it is actually getting less and less positive. So if you draw a tangent here, this value could be like 10 positive. If you draw a tangent here, the value could be something like 5. So it's getting less and less. So you can imagine that this is a curve. Let me probably erase some of this, okay, and get back the pen so you can see clearly. So you imagine the curve would going to be, it's going to be positive side of the x-axis, on top of the above x-axis, but it's getting less and less in terms of its value, and it's going to cut here. I did not do a good job, but cut here, and this is the inflection point. At the inflection point, what will happen to the f prime curve is that it's going to do a U-turn, because it's going to go from convex to concave, or concave to convex. In this case, you notice that here is where you see the concave. This is the convex part of the diagram. So there's a change of concavity, I mean. So this is the curve. It's going to go down here, cuts through this, and it's going to do a U-turn. So what you need to do is you show that this is the U-turn back to here, and it's going to tend to 0. Why? And remember this part is that we know that the slope tends to be 0 when x tends to infinity. So this would going to touch, no, it's not going to touch, but it tends to be really close to x-axis, and of course the value 0. So this is your diagram again. There's something like this. So it would look something like this, U-turn, and then just go like this, but it would never cross the x-axis again. Just go like a, so the x-axis would like a asymptote. So that's the solution for question 1 and question 2.